All right, let's look at the second part. Now, we're looking as x approaches 0, so first focus on that x value 0. That's right here on the y-axis. We want to approach it from the left. That's what the negative superscript means. So I'm going to start here on the left from, like, say, -2. I'm approaching 0, I'm approaching 0, I'm approaching 0. As I get really close to 0, the y values just keep plummeting all the way down to nothing. So the limit should be actually 0 right here. Now, I know that the function value at 0 is 2. So f of 0 is 2. But they're not saying find the function value of 0. They're saying get really, really close, but never touch 0. Just what would you predict if you can't see what the function value is? Like you have this fog covering the x value 0. As I approach values really close to 0, I would predict that my limit is 0. Different from a function value. So your limit is not 2. Your limit should be 0, even though your function value itself is 2. So this one is false. On to the next part. All right, we want to look as we're still approaching 0. All right, we want to see if you approach from the left and you approach from the right, we're saying, are those the same thing? Well, as you approach from the left, your limit 0. As you approach from the right, your limit 0. I don't care about my function value. That's not the same thing as a limit. Sometimes it's coincidentally the same. This time it's not. Your limits from the left and the right are both 0. They agree. So that means your limit as x approaches 0 in general is 0. So these limits, left and right limits, agree with each other. So this one's true. For the next part, we're asked if the limit as x approaches 0 exists, which means this isn't specifying from the left or the right, it's just if you exist in general. And remember, that's conditional on if the left and the right agree. We said the left and the right do agree. So if the left and right agree, your limit as x approaches 0 in general, neither specifically left nor right, does exist. So this one's going to be true. All right, and we also kind of answered this one early. The limits left and right agree, which means the limit does exist. What is the limit as x approaches 0? Not specifying to the left or the right means, in general, the left and the right together, since the left and right both have a limit of 0. That means the limit does, in fact, as you approach 0, equal to 0. So this last part would be true. Did I say last part? Ha ha, silly me. There's one more part. So the limit as x approaches 2, be careful here. If it said as x approaches 2 from the left, okay, approach 2 from the left, yeah, that limit's 4. If it said as x approaches 2 from the right, which would be a little plus superscript, that would be 0. So as x approaches 2 in general, the left says 4. From the right, it says 0. If the left and right don't agree, not only is this limit not equal to 4, it's not equal to 0. It doesn't exist because if your left and your right don't agree, you can think of it this way. If your left limit does not equal your right limit, then that means your limit does not exist. So your limit, your general limit, I call it, does not exist. All right, that's the end of number 8. Okay, so here's an example of number 8. Now, what they're asking is, you want to be very careful with the signs here. The limit as x approaches -2, that preceding minus is a -2, so that's this domain value, from the right. So we want to go to -2, but from the right side. We don't want to approach -2 from here. We approach it from, like, say start at 0 and head towards, the left. So it's from the right, meaning you're heading left. All right, as I go from the right and I go really, really close to -2, my y values get really, really close to the y value 4. Now, I know there's a closed dot at 4, so the function value at -2 is 4. But even if there were an open circle here, if that circle were open instead of closed, the limit would still be positive 4. So that one would be true. The limit as you approach from the right is 4. Okay, these are some selected items from the study guide. I'm working number 7 right here. This is where you take the limit as x approaches 0 of sine of something x over something x. Now, using just your calculator, okay, I put this into my calculator. I want the limit as x approaches 0. And obviously, so I'll go to my table. And by the way, I have my table set to ASK. That's all that matters here. That doesn't matter this table start, doesn't matter. Delta table, doesn't matter. Independent is set to ASK. Dependent auto generates. That's all you need to worry about. Now, try to plug in 0. So we can cheat the limit. We get an error because we're dividing by 0. Because sine of 4 times 0 is 0. Well, let's try this thing at a tenth, which is pretty close to 0. All right, let's try a hundredth. That's even closer to 0. Let's try a thousandth, which is even closer to 0. Now let me get a little bigger here. Now, if you notice, as I get closer and closer to 0, try a thousandth. Okay, went over here. If you try a thousandth, all right, and let me try like a tiny number. 0.00001. If you notice the limit approaches 0.25, it's always going to be whatever the coefficient of this x is over this one, just to convince you, okay? Let's say I did sine of, let me go over here and second insert a 2 right here. That's 2x, and then replace that 4 with a, let's replace that with a 3. Now that would be 2/3, right? 2x, sine of 2x over sine of 3x, 2/3. So if that, is true, what I'd expect is when I go to my table is for it to approach 0.6 repeating, and in fact it does. So if you use tables, you can just figure it out. But the theme is that if you take the limit as x approaches 0 of sine of something x over something else x, it's always going to be that fraction. Let's say this is sine of ax over sine of bx. It's just going to be your fraction a over b. That's how you work number 7.